Welcome to Drink Scale Models. I'm Jason, your host, and I do models and apparently electronics. What's up with that? What are we talking about today? It's traffic light time again. Excuse me. And I have not moved forward on the project as much as I would like because I was stuck on a design system. My original system was using a Uno on a breadboard to come up with the programming, and with the list of features that I wanted to add to this traffic light project, the coding became a little bit of a nightmare. I could probably pull up what the code looked like here. Let me just check my code here and see if I can pull it up and show it to you. Version 4. So I have 4 versions of the code, and I'll show you where I am left with on this. It's loading. So I have come up with a modular system that is going to allow for upgrades. It will also be including a custom PCB that I will be making I'm probably going to make it on camera when I get the parts worked out and draw the schematic up, because I'm still working on the schematic. So this is just going to load up here, and anyway, it was in the beginning I'm using an Uno to program everything. And then I was going to switch to something like this. So let me move this over here. So I was going to switch to something like this, but let's take a look at the program that I have here. So this is the program. This is version 4. So I have the potentiometer to adjust the time frame. Now this only contains a north set of lights and an east set of lights. No south and no west. This is basically 6 LEDs running this program. And then it has, where's the interrupt at here? There's an interrupt, and here it is. I'm setting an interrupt here. On timer 1 to interrupt, and that interrupt is running this down here. This reads the analog value, and then it maps that value to C1 time, and then in the actual program it would run the north and southbound lights green, run the north and southbound lights yellow, and then there would be a all red with a red delay time, and then it would switch over to the east and west bound lights, and that time was adjustable with the potentiometer. And then there was these separate functions down at the bottom for each set of lights. And I ran into issues with timing that the potentiometer map value that was... Where's the map value? This map value, I had to keep adjusting this to get the right 5 to 10 second delay or the 5 to 10 second green time, and it was way longer than 5 seconds and way longer than 10 seconds, and no matter what I changed on this, I couldn't get it down, so I was having a lot of issues with timing. And instead of using 6 pins for 6 lights and then adding another 6 lights and just using 6 pins, I wanted to add turn signals and things, so I was going to have almost 12 pins, and that was too much to take up. So what my next way of doing it is using shift registers. So I'm going to use shift registers, a set of shift registers for the northbound lights, and a set of shift registers for, or the north and southbound lights will have a set of shift registers, and then the east and west lights will have a shift register, and that way I can have 8 lights on each shift register using only 3 pins, and that way I can have the northbound lights, the southbound lights, and turn signals. So 2 turn signals. So that gives me the 8 on each shift register and the same on the east and west side. So I was going to use in the final project, I was going to use one of these nanos here. This is an Arduino Nano, and just run a bunch of wires and do it that way. And then I was like, well, this is going to be kind of weird and kind of wonky. So I was trying to come up with a way to use a modular system to do this, and then I got into what I was going to use for power itself. And I came across this broken USB power bank, and the USB-C port was broken on it. I ended up fixing it, but I decided in the end I'm not going to fix it. I'm going to salvage this battery out of here and use it for a power source for a new modular system that I have planned for this project. And the modular system is going to be based on this power system I showed in other videos with the USB ports on it, and it is going to have these little modules using these Atmega AT85s, I believe, and A-Tiny85. So it has 3 pins that can run the shift registers, plus it has timers and interrupts and 1 analog input for the potentiometer. So I could do a northbound module, and the board I'm going to make is going to have more than 2 USB ports on it, but you would take your northbound module, plug it in, and then you could take your eastbound module, plug it in, and then your lights would go on one of these boards that have like a JST connector or some kind of header system, so you could just clip in your sets of lights. And the power source is going to be based on one of these battery charge circuits, but I'm going to design it with 4 double stacked USB ports, so the USB ports will be too high, so you could plug in a board like this, and then on the second one you could plug in a board on top, and then you could have JST connectors connected to each module, and you'll have a completely modular system. So as you add things to the project, you're not going in and trying to add code and then making all the timing works out. Because with the timing, if you want any sort of interrupts, you get one software interrupt basically, and then you can have on the regular Arduino you can have 2 hardware interrupts. I'm not sure how many hardware interrupts are on these AT-Tiny 85s, but there is you can use these boards for simpler projects here, but I have my eye set on another, let me pull it up here, another type of board that I plan on using for some of the modules that tend to be more complicated, and it may end up being it may be the actual hold on a second, I'm just typing. For the traffic lights. So let me see if I can find it here. Here it is right here. So I'm going to show you this right here. So this is from Amazon. This is a this has an actual Atmel mega chip on it. It has the A32U4, and this actually has more pins on it, and it also has more input pins. So these boards would clip and plug in too. But my goal is to use these AT85s for smaller modules that you want to build to add to, let's see if I can do this. No, I can't add monitor. So let me move that there. Let me do this. Let me do one. So plan on using this chip for more complicated modules that need more inputs and outputs, and then using the AT Tiny 85 for simpler modules, like maybe a servo that is just doing like running a train crossing. So you could do, so say you have a train crossing, you could do program up your train crossing, hook it to a wiring rig, and then just plug it in to one of the USB ports, and then you have a working railroad crossing system. And then the same thing goes with lights. You can have street lights that have a flicker or any kind of, system that runs at night or night mode or anything like that, and you just program your module, you plug it in, and then that way you don't have to change all the code for your standard, if you're doing just some traffic lights and you want to add and expand to it in the future. You can just plug a new module into a power board. So, and then this is going to also have, this right now does 5 volts. It's also going to have a set of headers on the side of the one that I'm going to design that will be a solid 5 volt rail for servos and whatnot, so you can't power some of those with the Adrenos. So you'll have a separate power header, probably 3 JSTs that will plug into the side that you can power your servos from. I could expand it to 3 on each side so you could power 6 servos, but I'm going to limit the first revision of the power board to have 6 USB ports on it, 6 double stacked USB ports, so it'll be about this wide, the width of my fingers, so a little bit wider than this. It'll have 6 double stacked USB ports on it. It'll have a charging port, a 5 volt charging port, and then it'll have the charge circuitry, the battery protection circuitry, and I'm not going to put the display on it like on this module here. I'm going to go with a probably a 4 light LED system that if you press a button, it'll tell you how much charge you have in your battery pack. And then if you, when the batteries do start to get low, an LED will pulse flash for like 3 flashes and then stop flashing, and then 3 flashes and stop flashing. And also, it'll start cutting power to your modules, and then it'll let you know that you can recharge your rechargeable battery, or you can just run the whole thing off of the USB input on the module itself. So I'm debating on a micro USB port, but if I have room for the module, I would like to have USB-C. It's a little bit more durable of a port than a micro port, so I might do that, and then you'll have that. And then if you need to change the program, you just basically unplug your module, unhook your wiring harnesses, plug this back into your computer, and reprogram it, and that's it. You're done. You can just hook back up and replug it back in. So you could change your schemes for different holidays. You could have a layout with a holiday scene with decorations that light up, and you could plug in a Christmas module and then just hook up the lights, and then that you could do a spring, summertime fireworks, whatever you want to do, you can do with a modular system like this. And this is my goal here, is to make a modular system. I'm designing all this as I go. I thought about what I want to do for the project, and it has gone through many revisions. As you saw in the program, it was on revision 4, and now I am going to revise to revision 5 later today when I work on coding these little modules itself. I'm going to go ahead and solder some headers, some DuPont headers on these, and then I will start programming these for the east and west sides and the north and south with shift registers to show how these modules can run a individual light unit. So that is the goal for right now. So I'm going to get programming on this, and this is going to do it for this video. It's just a short talk about how I'm going to turn this into a modular system, starting with 6 USB ports, and then I may expand that to 8 depending on ideas from you guys. If you want to see a bigger one that can hold more modules, but a double stacked one where you do one right side up and one upside down is going to be my best option. And the parts aren't going to be too bad because this has more than it needs on it. It basically just needs a charging IC system, a battery protection IC system, and a boost circuit system to boost up to 5 volts. It doesn't need a button system. It doesn't need this flashlight system. It doesn't need a display system that's running this display. It just doesn't need all that stuff, and I can eliminate a lot of this. Have my USB input. And the USB input will probably be a JST connector, so you can have this inside underneath your module or in a house or something like that, and then you can just plug into it through a port on the side of the actual model to charge it, and you can just run a wiring loom of a JST type connector to this, and then in the end these will have connectors on them that work kind of the same way, where you would make a loom and then just plug it in, and then when you want to program it, pull it out, unhook the loom, and reprogram it. And then you do the same with each additional module. I may end up redesigning these boards also, and also the Beetle board, to make them a little bit wider and longer to be able to plug in like 3-pin modules for shift registers or servo modules or things like that, to where they're easily accessible with JST connectors. So I'd basically have to widen them enough to put JST connectors and rearrange the pin locations, so you would have 5 volts ground and a digital pin, or as the case for a shift register, you'd have 3 digital pins in a row. So I will come up with a way to lay out the pins so I can use header type like JST connectors or something like that. So that's for a later revision. This is where this project stands now. I'm going to be coding this today for these little AT85s. I'm working on getting some of the Beetles so I can work with those at a later date. But that's going to do it for this video, guys. I hope you're enjoying the project. It's taking a while. This is all stuff I'm designing on the fly. This is going to be super elaborate, super modular, and it's going to be a pretty neat system. But you can check me out on social media. You can also support the channel on Patreon if you so choose. Thank you so much, and I hope you guys have a fantastic day.